Thanks, folks. It's been a brilliant conference. Congratulations to organisers. I've really enjoyed the 2 days. It's been brilliant. Yeah, it's a closing keynote. We'll try and keep it exciting. So my name is David Anderson. I want to talk about creating momentum with the Value Flywheel Effect. I'm currently an architect and also worked on the book, Value Flywheel Effect. But first of all, I want to hit one question. I've been using this image probably for 10 years about the impending wave of change. And I previously had done a lot of work on serverless first at large organizations over the past probably 10 years. And people always say, why serverless as a technology? And I always say that's the wrong question to be asking. There's a wave of change coming, and we need to think differently about technology. And it's not just, is it a function or a container? That's the wrong conversation to be having. And the thing I've just been thinking about this past few months, there isn't, obviously the image is the great wave. The waves don't come in ones. There's always another wave behind it. And so the modernization keeps coming. So the fact that it's almost like, well, that is a flywheel, but it is that momentum. So once you get used to kind of embracing change, it never really stops. And I think the serverless mindset is brilliant for really thinking about that. I wrote a book must have been about, I think it was 3 years ago it came out, called The Value Flywheel Effect. And it's really been described as a handbook for cloud modernization. Myself, my two co-authors, Mark McCann and Mike O'Reilly, we worked for many years for Liberty Mutual, large US insurance company, and we created a kind of a serverless first framework. And I'd spent a lot of time talking to different kind of industry leaders, etc. And really nice forwards by Adrian Cockcroft and Simon Wardley. It was actually Adrian said to me, you need to write down what you've done. You've done some really exceptional work. You should write that down. So we kind of went about with IT Revolution and Gene Kim and Co. and published it. And it's had fantastic feedback. And really, for me, it's just about sharing the story of how we went about a huge modernization, which has been awesome. And it's been a really interesting journey. The Value Flywheel itself, and it's about one real simple thing. How do you join business and technology strategy? There's nothing that annoys me more than having two different approaches. It just doesn't make any sense. So we kind of, as I was writing the book and thinking about it, I come up with this idea of a value flywheel. And there's 4 phases. Clarity of purpose. The first thing you want to do is find your North Star. Why are you doing what you're doing? There's things like North Star framework. Then embrace challenge. Create an environment for success. A lot of my US colleagues will say, I don't think challenge is a very positive thing. Challenge is about asking questions. It's about having psychological safety. They say, why are we doing this? So I think it's really important. Then next best action, have the right technology set to go fast for your teams. And then finally, long-term value. Have a strong opinion about what good looks like and be something like the well-architected. And I've been using Wardley mapping for probably 12, 13 years just to make sense of situational awareness. So for me, it's Wardley mapping creates perspective. And again, it's really about joining these two things together. You see on the left side is probably more sort of on the right side is more probably team-orientated, about the right culture, the teams. The left side is more technology-orientated. That's on purpose. So as engineers, I mean, you'll say uncertainty is part of our job, but it's never been this uncertain. I think with the whole AI explosion this past 2 or 3 years, it's been absolutely insane. The amount of change is just, I've never been working in IT for a long time. I've never seen it this sort of, this much change. So I'd like to kind of frame that through a Wardley map. Many people are familiar with Wardley mapping? Hands up, a few. How many are comfortable with Wardley mapping? A lot fewer. So I kind of want to frame this as there's a few different things. So first of all, explain the structure of a Wardley map. So you start with an anchor with the kind of user at the top. Here I've got a CTO. So on the vertical axis is really that value chain. So it's kind of visibility. Things at the top are things that are in need by the customer or the user. As you go down, there's more kind of, it's less visible. So things at the bottom is value chain are less visible. And then from left to right is the evolutionary axis. So every component on this map will actually evolve from left to right. So if a component starts off as Genesis, so something Genesis, it's like, this is brand new. I'm not even sure how this is going to work. It's very experimental. It's like magic. Then as it evolves into custom, I think we know how to build this. We think we understand it, but we're still trying to figure it out. Then into kind of product, there's now customer need, customer demand for this. And finally into commodity, this is just the cost of doing business. So for this map, I've slightly changed it. I've used the terms as well, concept, hypothesis, theory, and accepted around some of these components, because really what I'm mapping out here is an organizational pattern. So a CTO has a need to drive change, okay? So let's just say, for the sake of argument, that they have their goals, their clarity of purpose is quite clear and quite understood, well understood. For the environment, for the teams, the attitude, let's say there's fear. There's fear of the unknown. You have teams that aren't quite sure what this change will look like. And the little black mark there is an inertia barrier. Like what's stopping teams? And for me, like what you want to get people is an attitude of curiosity. Let's embrace the change. Let's see what happens. But it's psychological safety is that inertia. Maybe the teams don't feel like they're safe. For me, a big part of this is it was covered earlier by Rich and Faye. It's this idea of socio-technical. We often think of the technology as it's just a system, but you also think about what are the teams and what are the needs of the teams. So something psychological safety is incredibly important. It's more than code. And I put the responsibility for this firmly in the camp of leadership. As a leader, it's your job to create that environment for success. I don't want leaders dropping in the code, going shoulder to shoulder with engineers. I don't want them deciding what to build. They have to build great teams. It's job number one. I really like this idea of, this is a nice image by Motomuro, I think they're a consultancy, around the 4 stages of psychological safety. I thought this was brilliant. We think of permission and respect. So probably the worst case is exclusion. There's a conversation happening somewhere. There's people making decisions. I'm not even in the room. I can't even talk about this. That is the worst scenario. Then you get to inclusion safety. So I'm now in the conversation, but maybe I don't really feel like I'm empowered to speak. So I'm in the room, but I don't really want to share anything. Then you get to the point, well, I'm in the room and we're all learning, which is fair enough. So we're realizing that we're trying to figure this out, but I still maybe I'm not quite sure of what my role in that is. Then you get to contributor. Now I feel fairly open that I can share my thoughts. I've been making me slightly vulnerable in the meeting. And then finally, again, I mentioned the term challenge. I feel safe to challenge the status quo. If my tech leader, team lead, says something stupid, which they often do, I feel empowered enough to say, I'm sorry, I think you're incorrect there. This is a better idea. So I really value the importance of challenge in teams. Without it, I think it's really difficult to do some of the stuff that we talk about. So again, for each, I want to talk about some inertia points as we go through this. There is an inertia point here around knowledge versus expertise. It's like in this room, we've got knowledge. We're taking time out of our busy schedules to go to a conference to learn. That's experience and knowledge. When you look at LinkedIn, sorry, that's expertise. When you look at LinkedIn, there's knowledge. You have people posting about AI who haven't written a line of code for 15 years, thinking, I know what this is like. I used to do this. Knowledge expires. Expertise stays fresh. One of the things as well I think is incredibly important is this idea of the business. When you have psychological safety, you hear people say, or you don't have it, the business won't let us do that. If you're a badged employee for a company, you have the agency to decide what needs to happen. It's as simple as that. We can't hire smart people and then say, we're not going to let you do what you're trained to do. So I hate this term, the business. I would like to eradicate it. It's we are part of this company. We're trying to figure stuff out for our customers. So I think that idea of safety is really important. So let's assume we've created safety. We've now created an attitude of curiosity. Let's talk about the right technology. So say, for example, you're a CTO. You've got good teams working well. How do we create some technology with impact? Like a serverless technology strategy, we'll say. How do I move that from left to right? So I've called out 3 areas here. Engineering excellence, a system model, and platform engineering. We're just going to go through these 3 things quite fairly quickly. So platform engineering, I think this event has been incredible. There's been so many conversations with platforms. I think we have a good idea what platforms are. One of the things I think is I've spent a lot of time working on AWS systems and AWS kind of architectures. And Werner Vogel's, I think it was 2 or 3 years at reInvent, had a big feature on EDA, event-driven architecture. And I think, for me, if you think of cloud first principles, it is event-driven architecture. It's completely asynchronous, and that's how things scale. So when you break that down to how we think of our systems, you think of single-purpose functions, clear boundaries, async communications, and then there's actually underlying technical strategies under that. So we have to make it easy for engineers to build these type of systems. As cloud becomes more and more of a first-class citizen, like this is the way we will build systems. And I think we're still catching up to that. There's a really interesting overlap here with, I would say, systems thinking. I find this is really nice from the SI Tech Hub, the systems innovators. These three things about system constraints. Purpose. Purpose is a way to align people into a certain goal, to stop people kind of steering off the road. Context gives people that idea of like, what's the context we need to create this system? Like, will this technology work? You don't want people doing technology for technology's sake. And then finally, decentralization. One of the biggest things I see in building serverless, event-driven systems is the lack of decentralization. If you have an old engineering manager from maybe 20 years ago, they'll try and centralize things. We should create a reusable team to do this, bottleneck. We should create one team who know all this, bottleneck. That idea of decentralization. And again, that's for me, enablement is a key part of that. A good enablement team will enable a function and then go away. One of the things I think is very cool for this that I would use a lot is Event Catalog by David Bowney. This is a brilliant tool for cataloging events and APIs. It's almost like it's like a catalog for all your synchronized and asynchronized kind of messages. Really what that is, it's making visible the entire system to everyone in your organization, which again is a form of constraint. It's like a gentle constraint. I think this is a brilliant tool, and again, I know David, it's an open source tool, it's fantastic. One of the things I think is super interesting, and again, I've been following DevOps since before it came about, that I get the feeling DevOps has forgotten about the developer. If I'm an engineer creating event-driven systems on the cloud with domain-driven design, someone give me an API or a container isn't really going to help me. That's a solved problem. I don't need a better API for a container. I want someone to help me with my domain, my ubiquitous language. There's lots of different things around event-driven that are important. A lot of the DevOps teams, the previous sysadmins, it's just about cloud infrastructure. Again, we get that from providers. So I do get the feeling DevOps has forgotten about the developer, especially with event-driven architectures. So the second thing we talk about is system modeling. So I love this thing from XP called the system metaphor. A system metaphor is a story that everyone, customers, programmers, managers, can tell about how the system works. This is a quote from Kent Beck, probably about 20 years old, I'd say. If you look at these things across the bottom, libraries, agents, models, cookies, bus, etc., these are all things that we think about, and you think about something in technology, but they all came from a metaphor from the real world. When you think of when you're building a system, you don't want to sit with your president of your business and start drawing boxes and talking about lambdas and containers and stuff. You'll just instantly lose them. Think of a metaphor to bring your stakeholders along with you. I think this is really powerful, and maybe it's something we've forgotten about. Even Big Ball of Mud, again from Brian Foote's paper, is a brilliant metaphor. One thing that I often would use, you need a metaphor in the large to bring people with you. You also need atomic habits in the small. When you think about long-term value, one of the things that I've been using for a few years' time, this idea, it's a process I call SCORP, which stands for security, cost, operational reliability, and performance. And this is from the well-architected framework from AWS. Again, all the cloud providers have a well-architected framework, but I thought this was a real nice one. So we have a low-fidelity process that every team for every sprint to capture how are you trending against your SCORP metrics. So you have a facilitated session. I think so. Well-architected traditionally was a very kind of heavy process. There's a white paper out there, but we've kind of turned it into a lightweight process. The process, I think, is brilliant, and it's so valuable. You'll say to a team, create a low-fidelity dashboard, something maybe on a wiki or something really straightforward, and pull out metrics that you believe are important that hit the 5 pillars. Here you see performance, cost, and security. Like many vulnerabilities, what's your cost of your compute, what's your performance of your functions or services, and then usually a SCORP facilitator, not a scorpion, usually an architect or a staff engineer, will sit with the team and just discuss the dashboard. Again, in a safe environment, say like, oh, I see that Lambda really spiked up last month. What happened? Oh, we're not sure. So it's a forum, it's a safe space to discuss non-functional requirements and actual things in production. And often we'll have several teams join that session so they can compare and learn from each other. I do have some SCORP stuff up on the serverlessedge.com. You'll see it there, the process. It's a brilliant process. It's used now by hundreds of teams. It's just how you really celebrate engineering excellence. One thing, if you think about that metaphor, like we had some conversations yesterday about the factory metaphor. I think of systems as a garden. You have to think big. What's your big metaphor? What's your big vision, which may be several years away? And then your small atomic habits, where you'll sit and prune things and weed. So it's almost like think big and plan, plant, prune, work, and that's how you enjoy a good system. So again, it's a slightly different way, and I think you do require a level of ambition to think good and really refine in the small. So that was system thinking. And finally, engineering excellence. So the serverless first mindset, again, this is very often misunderstood. Serverless is an operational construct. So what that means is you're reducing operations for your team. So if you have a stream-aligned team, maybe there's a platform team that are doing the operations for them. That's still not good enough. We want to, you build it, you own it, you run it. You want a team to say they own the account, they own the operations, and with serverless services, they can do less work. This is an image probably from a good maybe 8 years ago that shows this kind of spectrum. On the left, there's things that are more operations, on-prem, containers, etc. On the right, you have things like Lambda, S3, a whole bunch of services that it's an API call. Okay, that's a mindset shift. What I would always say to teams, start on the right and fall back. Choose a serverless service and then fall back if it doesn't do what you need. Again, less operational overhead, reduce your operational burden, and you've got scalability, you have cost built in, and you're event-driven, so it hits all the boxes kind of for free. One of the things that I'll do, and again, if you're doing recently, is when you're working with a team, that will start off with the pathway is quite straightforward. We'll say if you're building your microservice or your bounded context, start off with Lambda for compute, API gateway for your APIs, event bridge for your events, step function for orchestration, Dynamo for storage, and then we'll architect it for your quality. Once you reduce the technology set, that reduces your cognitive load. And then as you need more things, you can bring more things in. Obviously, this is an AWS shop, but I think it's the same principle applies. Reduce the kind of the choices to get that standardization. A big inertia point here is people will often equate serverless to Lambda. So think, you're asking me to do this, you're just asking me to build everything in a function. It's missing the point. So let's say, for sake of argument, the CTO who wants to drive change, they've got their goals, they've brought psychological safety in, the attitude of curiosity. You've done a lot of modernization work. We've now got a really solid technology strategy. We're squared away, our platform engineering, system model, engineer excellence. What next? A senior stakeholder says, let's leverage AI. And you go, oh my God, here we go. So somebody will do a flashy POC, which has its place, but they rarely evolve out of Genesis. They usually die in Genesis. The POC will come in, everyone gets excited, it'll die. It's good for getting attention, but that's not really the main show in town. There's a new path, I think, and I think the concept of AI native development is super interesting. So it's almost like, what happens after modernization? What can I build upon to do something? So if you look at there's a value chain here around AI native development. There are new agents that we could use, and they rely on a shared context. Guess what else relies on a shared context? A really good system. So you'll probably build that shared context through all of the, your technology strategy, regardless. The context is just information. If you build a good domain-driven, event-driven design or system, you'll have that shared context. So let's go through that. One of the things that I find fascinating, and again, I seen this a long time ago and so it stuck with me, code is a liability. It's the system as the asset that you should be building. A lot of stakeholders will say, let's use AI to generate all the code. You're just creating more crap. That's never the problem. So we have to think in systems as we're building these things. In my experience over the last few years, AI in the cloud especially requires strategic thinking. It is like a game of chess. You got to think several moves ahead. What happens when this capability evolves? What then? What next? What next? And that's why I use wordly mapping, because I think it's really interesting to actually, you can see several moves ahead in your technology strategy and build the right thing, and then also choose what you should not build. And there's never been a time where this has been more important, to think strategically about your technology, your choices, and your capabilities. So I want to show a quick case study in the last few minutes. So I'm currently working with a company called GP. There's two interesting products. The stuff on the left is kind of employment of record. What GP do is they'll help companies employ people in different countries. If you're here in England and you want to employ someone in France, GP is an entity in France that you can employ that person. So that's the core business. And then there's a new product, which is GIA, which is basically advice. So I'd like to talk about three quick things, how we have kind of embraced AI native development within the company. I think it's really interesting. So this is like we've been through the modernization journey. One thing I think is really interesting is if you think about AI development agents, there's a parallel to the self-driving cars, the 5 levels of self-driving cars. This is from an article from AI Native Dev. Level 1 is coding assist, autocomplete. And you get up towards like autonomy, maybe creating tests. Then you get to conditional, maybe specification driven. Then high autonomy, maybe handling development, and then full autonomy. Just like self-driving cars, level 5 is like a pipe dream. Like if you really want to have your Tesla drive you home, good luck. It's like YOLO mode, you only live once. Exactly the same as AI development. So I would say probably 2 years ago, we started on level 1. We're probably almost at level 3 now. We're experimenting with level 3. There's a really nice, again, I think this is a nice illustration. AWS have brought out the Kiro tool, which again, regardless, but what's really nice here is as part of the AI DLC, it's specification driven. So if these 3 phases, inception, we have your kind of your PRD, your requirement, your specification. Construction, where you kind of start building out your tasks, and then operation, deployment. So I'm seeing these 3 things. But again, the common pattern is not how well it writes the code, is who writes the spec. Still an unanswered question. At the minute, it's usually engineers who write the spec, but that's not right. So what I'm seeing as a real obstacle for those 5 levels is, can product managers write all the specs required for these systems? And the answer is no. It's really difficult to do that, even for engineers. So the first thing is, how does AI affect sort of how we develop software? The second thing is, I've got a second map here, so apologies, I can't stop myself. We used this map a few months ago to explain. As we started the AI journey a couple of years ago, the first thing we did was let's create this new product, GIA. So if customers want HR advice, there's a bunch of compliance, there's an advisory runtime, and then there's a GIA reasoning. That's a custom patent pending kind of model that we have written with a couple of AI experts, actual researchers who wrote that. So that's, you know, some real smarts in there with our data. Then there was a second stream, the value chain, which is how do we do tasks. So the user has something to do, like maybe check a timesheet. We need an agentic runtime. We need something to run that to connect through our APIs. So it was really interesting when I wordly mapped this up. You could see there's 2 different types of agent. There's our custom model, which we wrote and spent several years at, fine-tuning. We wrote it ourselves because we need to know how that works, very specific. And then there's the stuff on the right, which is built on Bedrock, AWS Bedrock Agent Core, We know the agent runtimes will evolve rapidly. I don't want our teams to build an agent runtime for this, because that is commodity. Like you see, even OpenAI brought out their, I think it was Agent Kit last week. This is going to evolve at a rate nuts. I don't want our teams writing their runtime. So we specifically had 2 different approaches, technical strategies, for how we build our AI product, and then how we open up agentic capabilities to our teams. That was, and this is really important to explain to stakeholders why there's 2 different flavors of AI running. It's not on competition, it's 2 different user needs. And then finally, the thing I think hasn't really been talked about an awful lot is how do you enable like this agentic development within an organization. So I was actually using a team topologies kind of system here to explain this. So if we have streamlined teams who have a need to create agentic capability within the streams, we have a small community of practice that are helping those teams. So they're helping those teams with recipe creation or prompt creation. How do I write a prompt that will work in the space? We have our designers with experience design. How do we? What does the design experience look like for a user when they interact with these agents? Then we have a very thin platform team that are wiring a few things together to make this runtime available internally. It's really like it's almost like a glorified enablement team. We have our AI experts in our lab who are advising on some of the more cutting edge things, and then of course we have security around our kind of guardrails. And then finally, the real platform team is AWS. It's the AWS, it's the Bedrock Agent Core. The interesting thing about this, 6 months ago, our guys were like, we're going to write an agent runtime ourselves. And we're like, hang on a second, something will come out. This Agent Core was launched, I think, on the 17th of July. We had it up and running on the 18th of July. We just rapidly accelerated that whole runtime. And it's evolved. I think it went GA about 2 or 3 days ago. So that really has been able to accelerate. So we're focusing on probably the top of this picture and letting the bottom half be part of our platform. So again, it's really interesting way how we enable this agentic development in the organization. So again, that kind of shows how once you go through that modernization journey, create the right environment, the right tech stack, then you can open up for new, I would say, more exciting development. So in summary of the 4 things, I would say, gift yourself a good environment with psychological safety. Do not accept anything less. Your platform must help engineers build better systems. We've heard that message loud and clear this past 2 days. Context is extremely important, how you think about your systems and how you describe your systems. You have to write down what your domains, your APIs, your events do. Offload your operational overhead to your cloud provider. Again, for me, it's AWS, but whoever that is, offload them and you solve the problems that you need to solve. Whether you use AI or not, these foundational items stand up. But if you do have to leverage AI, these will help accelerate. And I would say embrace uncertainty. Don't back down. Don't cower under thinking AI's changed everything. Double down. So that's the value flywheel. For me, that's when you really commit to modernization, I think that flywheel keeps turning. I often get asked, why is it a flywheel and not like a waterfall? Because it keeps spinning. These things keep going. So I think that's almost me. Again, the book's around. We do have a podcast. Myself, Mark, and Mike will talk absolute nonsense about things, so it's not very serious. But please dial in if you want some entertainment. Again, I'm around today. I've really enjoyed the event, so thanks for listening. I really appreciate it. Thank you.